The structure of the functional group of alcohol is also another important discussion. Structure of the functional group. Here you have to understand is actually a water derivative. Oxygen is here, hydrogen is attached here, and instead of another hydrogen in the water molecule, the carbon of an organic compound is found. And also the bond between oxygen and the carbon in the alcohol is sigma bond. And also the bond between oxygen and hydrogen is also a sigma bond. And the two lone pairs are found. Lone pairs are the pair of electrons which are not involved in the bond formation. And then this carbon will have another three bonds. If it is an sp3 hybridized one, it is all sigma bonds, or if it is sp2, then one pi bond will also be present. And if you look at a methane, methane carbon is also sp3 hybridized. Methane carbon is sp3 hybridized, and the bond angle is found to be 109 degree 30 minutes. 109 degree 30 minutes. Water is also sp3 hybridized. Oxygen, water is also sp3 hybridized with lone pairs occupying the two vertices of a tetrahedron. Now the bond angle here is 104 degree 30 minutes. See, the bond angle reduction is due to the lone pair bond pair repulsion, because the lone pairs are repelling the bond pair electrons. Therefore, the bond is still bent. So it is 104 degree 30 minutes. And in the case of ammonia, it is also sp3 hybridized, but ammonia has only one lone pair, which is occupying one of the vertices of the tetrahedron. And because of the bond pair lone pair interaction, ammonia, the bond angle is 107 degree 28 minutes. 7 degree 28 minutes. But in the case of alcohol, it is 108 degree 9 minutes. Or 108.9 degree, 8.9 degree or 108 degree 54 minutes. So that is about the alcohol. But in the case of ether, on both sides, carbons are attached. Ether, it is 110 degree. 110 degree in the case of ether. So the bond angle is due to either the steric group hindrance, a bulky group just expanding the structure, or due to the lone pair bond pair interaction. So the bond angle and the structure of the functional group is very important. There are questions asked in this also. So look here, one question is asked, what is the bond angle between the COC bond? It is 110 degree, which is greater than 109 degree 28 minutes, the normal tetrahedral structure. Right. Now, the preparation of alcohols. How alcohols are prepared. The first preparation is nucleophilic substitution of alkyl halides. Nucleophilic substitution. Nucleophilic substitution of alkyl halides. You have to watch closely now. What is a nucleophile? Nucleophile means the one which loves the nucleus, which means that it is getting attracted towards a positive charge. So the nucleophile has to be negatively charged so that this will run towards the positively charged nucleus. OH minus group is a nucleophile. And also, the reaction is called a substitution reaction. Substitution means one thing which is already present is taken off and another thing is placed in its place. So the substitution means there is something going to be removed, and that removing and that group that is removed should also be negatively charged. That is why it should also be a nucleophile. So in the case of alkyl halides or X, this X is the leaving group, which is also a nucleophile. And the OH minus is the attacking group, which is also a nucleophile. So the OH minus comes and replaces X minus. This is nucleophilic substitution reaction. The nucleophilic substitution reaction, if the rate of the reaction depends upon the concentration of alkyl halide and the OH group, then it is called second order kinetics. Such reactions are called SN2 reactions, second order nucleophilic substitution. If the reaction order is or the reaction is controlled only by the concentration of alkyl halide, it is first order reaction. It is SN1 reaction. Normally, in the SN2 reactions, primary alcohols are synthesized. In the SN1 reaction, secondary alcohols are synthesized. So primary alcohols are synthesized from the SN2 reaction. The secondary alcohols are synthesized in the SN1 reaction. This is the first method of preparation. Second method of preparation is, it is by hydration of alkenes. Hydration of alkenes. Enes, organic compounds with double bonds. Hydration means addition of water. Hydration, addition of water. Removal of water is called dehydration. So the addition of water across the double bond of an alkene is called hydration of alkene. But this reaction is taking place in the reaction condition, that is in the presence of concentrated sulfuric acid. You should know a particular thing about sulfuric acid, which is a powerful dehydrating agent. Sulfuric acid. Sometimes now acids are used in various conditions. In acid condition means hydrochloric acid can be added, sulfuric acid can be added, nitric acid can be added. What are the differences among these three acids? If you want H plus alone to be active, use hydrochloric acid. If you want H plus along with dehydration, use sulfuric acid. You want H plus along with the oxidation, use nitric acid. That is the difference between the usage of these three acids. Now, in the presence of concentrated sulfuric acid, when water molecule is added to alkenes, now look at an alkene. This is an alkene, CH3, CH, double bond, CH2 is an alkene. And I am adding water in the presence of sulfuric acid, concentrated sulfuric acid. Now what happens now? The water becomes H plus and OH minus. H plus and OH minus. This double bond, see, each bond is carrying 2 electrons. So this double bond can become, watch closely, one bond can break and the 2 electrons may be shifted to this carbon. Or the 2 electrons can be shifted to the carbon on the other side, here. If this takes place, the intermediate formed is CH3, CH plus CH2 minus. Because excess electrons are found on this carbon. This is a covalent bond. The double bond is containing electron of this carbon and this carbon. Now both the carbons fall on this carbon, so that becomes negatively charged. This carbon has lost its electron also, so it is positively charged. This is negatively charged. If this transformation takes place, then this carbon becomes negative and the CH2 carbon becomes positive. So now this OH minus can go over here because of the Coulombic force, and this H plus can come over here. Or this OH can come over here and this H plus can come over here. Actually, what happens is, this is what is favored, but this is not favored. Because this is a carbocation, the secondary carbocation is more stable than the primary carbocation. This is a secondary carbocation. As the secondary carbocation is more stable than the primary carbocation, the H plus goes to that carbon which has the negative charge, but here it is that carbon which has more number of hydrogens. Therefore, the product formed is CH3, CH, OH comes to this carbon, and then this is already CH2 and the hydrogen is getting attached here. So the product formed is this. This is called Markovnikov's rule. So according to Markovnikov's rule, the proton from the water or proton from any other source is going to that carbon which has more number of hydrogen atoms. So according to Markovnikov's rule, the alcohol that is formed is a secondary alcohol, where the OH group is attached to the second carbon and the hydrogen is going to the CH2, where there is more proton and the alcohol is thus formed. Suppose if the same reaction is carried out in the presence of peroxides. In the presence of peroxides, Markovnikov's rule is violated because the intermediate formed is not a carbocation. Therefore, anti-Markovnikov's addition is taking place. In such situations, the proton will be attached to that carbon containing less number of hydrogens, and the OH minus will be connected to that carbon which contains more number of hydrogen. In this case, if anti-Markovnikov's addition takes place, you will get a primary alcohol with the molecular formula CH3, CH2, CH2, OH. So this is how alcohol is prepared by the hydration of alkenes. Alcohol is prepared by the hydration of alkenes. Another method of alcohol synthesis is alcohol can also be synthesized from aldehydes and ketones. What is an aldehyde? RCHO. What is a ketone? RCOR. Look here, aldehyde is R C double bond O H. Ketone is R C double bond O R. And this carbon is called the carbonyl carbon. Carbonyl group, that C double bond O group is called carbonyl group. Now, from the compounds containing carbonyl groups, alcohols can be synthesized using a special reagent called Grignard reagent. First of all, the Grignard reagent is treated with the carbonyl compound in the presence of dry ether. Why dry ether? The reaction medium should not contain water molecules. It should never contain water molecules. Look here. Let me take a Grignard reagent. Grignard reagent general formula is RMgX, which is a magnesium salt. You know, magnesium has two bonds, right? The valency of magnesium is 2, which is an alkaline earth metal. To one bond, bromine is attached, and the other bond, some R group, maybe a methyl group or benzyl group, anything. What R group is attached. Now, what happens now? If this methyl magnesium bromide, look here, suppose if magnesium chloride is dissociated, it will become Mg plus 2 plus and 2Cl minus. I'm going to break either this bond or this bond. This is more ionic and this is more covalent. So in the dry ether condition, this is getting broken, not this one. In dry ether condition, this is getting broken, not this one. So what happens now? Suppose if I take C6H5 or Mg bromine. So in the place of R, a phenyl group is attached. In the place of X, a bromine is attached. If this reacts with formaldehyde, HCHO, formaldehyde, what happens now? Formaldehyde structure is this, a double bond O and X is here and H is here. Now, this phenyl magnesium bromide, phenyl group is detached. Magnesium bromide becomes MgBr plus because covalent bond is broken. And this becomes C6H5 minus. This is a different group and this is a different group. It is broken into two. This Grignard reagent is broken into two in the dry ether condition. And this carbonyl carbon, due to the large electronegativity of oxygen, the charge is getting concentrated on the oxygen and it becomes almost like this, CHH, and the carbon gains a positive charge and oxygen gains a negative charge. So what happens? This phenyl group is migrating towards the positive charge and the MgBr is migrating towards the negative charge. And what is finally formed is HC, here OMgBr, and here C6H5. Now, when this is hydrolyzed, hydrolysis means to break. Lysis means to break. Hydrolyzed means water getting broken. When it is hydrolyzed in acidic condition, again, water becomes OH minus and H plus. If this group leaves, it leaves us minus. So the OH plus is attached to the carbon and this becomes MgOH. So the product that is formed is C6, C6H5 OH and Mg, Br and OH. Another important thing is hydroboration. Hydroboration, again, a number of NEET questions are asked on hydroboration. Hydroboration. In the case of hydroborane, alkene, again, alkene is taken. Alkene is added with diborane. What you are getting is a trialkyl borane. Trialkyl borane. Trialkyl borane. And when this trialkyl borane is reacting with sodium hydroxide and hydrogen peroxide, you are getting alcohol. And to have an additional information, you should know what is diborane. Diborane is B2H6. Here, boron is here, another boron is here. Two hydrogens are attached. And the two more hydrogens are bridging hydrogens between this boron and this boron. This bond is called a banana bond. Banana bond. And the angle between these two hydrogens, 120 degree, but the angle between these two banana bond, 97 degree. It's called a banana bond. Now look here. I take CH3, CH, double bond CH2. An alkene is taken. When this alkene is reacting with B2H6, B2H6, the reaction is quite interesting. First, CH3, CH2, CH2, BH2 is formed. This is considered as BH3 twice. BH3 twice. When this particular product again reacts with CH3, CH, double bond CH2, it loses one more hydrogen, CH3, CH2, CH2, twice BH. Then this again reacts with CH3, CH, double bond CH2, CH3, CH2, CH2, thrice B, thrice B. So when this reacts with hydrogen peroxide and sodium hydroxide, you are getting CH3, CH2, CH2OH and boric acid BOH thrice. Now look here, two borons are there, right? Three alcohols are obtained. Therefore, the actual reaction is this. Actual reaction, the balanced reaction is this. 6 CH3, CH, double bond CH2, react with B2H6, B2H6, and you are getting 6 CH3, CH2, CH2OH, right? Plus 2 BOH thrice. This is what you are getting. I suppose you understand this. The next method is reduction of carbonyl compounds. In the reduction of carbonyl compounds, you can prepare alcohols from reduction of carbonyl compounds. There are two reducing agents, namely, you have to note down these two: lithium aluminium hydride and sodium boron borohydride. See, this is more reducing. This is less reducing. The reducing power is less reducing. Therefore, this reduces more active group. This is more reducing, but it does not reduce C double bond C. Therefore, you may be able to get C double bond COH. And there is one more reducing agent, sodium mercury H2O, in the presence of Raney nickel. It is also another reducing agent. So, for example, reactions CH3, C double bond O, CH3, acetone or dimethyl ketone. When it is reduced in the presence of lithium aluminium hydride, in presence of water, you are getting CH3, CH3, OH. Propentuol. Suppose you take benzoic acid, C6H5, C double bond O, OH, benzoic acid. When the benzoic acid is reduced in the presence of lithium aluminium hydride in water condition, you are getting C6H5, CH2OH, benzyl alcohol you are getting. See, when two or more functional groups are present, this is another special example. When two or more functional groups are present in a molecule, the less vigorous sodium borohydride is used as reducing agent to reduce the more reactive group. Say, for example, this particular point you should remember. Suppose R, C double bond O, CH2, C double bond O, OH. Watch here. One side it is carbonyl group of an acid. carbonyl group of an acid. On the other side, it is the carbonyl group of a ketone. So this is ketonic carbonyl group is more reactive, whereas carbonyl group of carboxylic acid is less reactive. So if I reduce this compound in the presence of sodium borohydrate, this sodium borohydrate is less vigorous. It is less reducing. Therefore, it will try to reduce the more reactive part. So the product that you are going to get now is RCHOH. Alcohol is formed in the place of the ketone, whereas the carboxylic acid group is maintained as such. So C double bond O OH. So this is what you are getting when sodium borohydrate is used as the reducing agent.